Hey, it's Brian, and I'm here with Wunji from Tactile Engineering, and we're here to talk about the Cadence Braille Display. Wunji, could you please just kind of give us a elevator pitch of what the Cadence is all about?
So the Cadence Display is a handheld device with an array of dots that go up and down, like a refreshable Braille display, but in an array of several hundred dots that can form pictures, multiple lines of Braille, or animation, so that blind individuals can access both text and graphics and animated images all in the same device.
So I've held one in my hand. It's solid. It feels great. It feels engineered great. Could you talk a little about the dimensions and the weight and a little bit about the battery life as well?
So the dimensions, it's about the size of a large iPhone, and it weighs a little bit more. I'm holding one in my hand right now. I'm sort of lifting the weight. Let's say half a pound. We've got these manufactured with metal bottoms for sturdiness, and in these injection molded tops that are molded in Indiana for resilience as well. As far as battery life goes, these things last for a really long time. The way our dots are designed, they latch, so that when they're up or down, they stay that way without the need for any power. So once an image is up, it can stay that way forever, and it doesn't eat any battery power. So like the device I'm holding now, I haven't charged this battery in 2 weeks, and it's still at 80%.
Very nice. So what are some of the other really cool features that make it stand apart from traditional Braille displays?
Well, aside from being an array, the fact that it has regulation Braille spacing means that you can read and learn how to read Braille as you would paper Braille. Our dots have a little bit of give, so it reduces finger fatigue, just like if you're reading paper Braille, where you can press down on the dots. You can also press down on ours. But the dots also can form images, and because our refresh rate is so high, we can actually do animation. You can put your hands on the screen, leave your hands on the screen, and the dots will move under your hand so you can see what's happening. You can feel a moving object. If you are looking at something under a microscope, you can feel like a planarium or a worm move under the microscope under your hand, and see that happening. You can watch an eclipse. We showed an eclipse at the Indianapolis Speedway this year. When it went to totality, we had a telescope hooked up to the Cadence, and blind visitors came to watch the eclipse live on the Cadence. We've done fireworks shows too, where we can show explosions from fireworks as they happen. You can put your hands on there and feel the fireworks burst under your fingertips.
And it's my understanding that at the other end, that people can actually see where the users are touching the screen, and it can actually be used in helping teach Braille as well.
Yes, teaching Braille is one of our major goals, especially when it comes to science and math, Nemeth code, and other kinds of Braille codes. When you're trying to learn advanced math and science, I'm sure as you know, audiobooks don't necessarily cut it. If you're trying to read a long equation or work a problem, you need to be able to have access to many lines of Braille and have access to any graphics that are associated with it, especially if you're working with a graph or a matrix or something that needs a visual component. So learning Braille, really important, and we have a number of applications that are designed so that even young children can start on this device and start to learn Braille as a tool. And when you mentioned the touch sensitivity, yes. So our next feature is that as people put their fingers on it and put their fingers pressed down on the dots, a teacher who doesn't have to be in the same room, they can be located remotely, hundreds of miles away, can see where the student is putting their fingers, where they're touching, and immediately give feedback and say, you're reading that wrong, or you're doing fine, keep going along that line, and help the student without having to physically drive to that location. We want to multiply the power and effectiveness of the TVIs we have, and who are already working very hard, and we want to make sure that they can help even more.
Absolutely. And I've seen over here on the table, you have 4 of them just laying right next to each other. They're able to almost share content across 4 of them at the same time. Is that not right?
Yes, that's correct. So you can link up to 4 of these to make a larger screen. A large screen is really useful if you're looking at a large map or a large image. A smaller screen's handy if you're trying to view something that's fast moving. If you're playing a video game, for example, it's easier to play that on a small screen. So that's why it's modular. Another reason it's modular was we wanted to make it easy on the user and the customer to be able to service and to be able to deal with any problems. It's a tactile device, and we recognize every device like this is going to eventually accumulate finger jam and gunk. That's sort of the nature of the beast. So what we decided to do when we designed it was, okay, we're going to make it as repairable as possible and as easy as possible so that when those problems happen, it won't be a burden. So we have a number of tools to help keep the machine working and to solve problems if and when they happen. And one of the reasons it breaks into 4 is, okay, so a dot went bad. That happens. But then you just take 1/4 of your display and send that to repair while you still have the rest of the display to be able to use for classwork, for work, and you're not left completely without a display during that time.
Excellent, excellent. Let's see, what else can we talk about? I understand that they may even work up in space.
Yes, so one of the projects we've done, because of the way the Cadence works, students at the Indiana School for the Blind and Visually Impaired use the Cadence to run mission control for a high-altitude balloon launch that we did here in Indiana in cooperation with Near Space Education. It's an Indiana nonprofit that does rocket launches and space launches. As it turns out, Indiana has quite a robust space industry. You wouldn't think it, but we actually do launch rockets here. So these students who were running mission control were using the Cadence to watch the balloon as it went up. And on that balloon, in October, we put one of our Cadence modules and sent that up to over 80,000 feet up in the atmosphere. We have these pictures of the curvature of the Earth and of the blackness of space, and there's our device sitting on there. And then it fell right back down through the atmosphere, landed in a pond somewhere in southeast Indiana. We went and recovered it and brought it back home, and it worked just fine. So we're pretty happy about that.
That is truly amazing. And speaking of students, don't the students at the Indiana School for the Blind, each one of them have one of these now?
Yes, we have several hundred of these deployed at the School for the Blind so that every student can have access to it and make use of it.
Fantastic. And if people want more information, can you tell them where to head to?
Absolutely. So we have a website, www.tactile-engineering.com, and we also have a YouTube channel. Just do a search for Tactile Engineering, and we'll pop right up.
All right. And finally, everybody's going to ask about price. I understand it's pretty comparable. Is that pretty fair to say?
It is pretty comparable per cell to displays that are out now. So an individual unit will run several $1,000s. Our goal, of course, is still to make sure that students and people who need them in the United States can get them through state and federal funds. Our goal, and our stated goal for starting this years ago, was that every student should have the accommodations they need to succeed in school, to pick the majors they want, and no student should have to pay for their own computers and accommodations. Every sighted student in Indiana gets a Chromebook. Every sighted student in Indiana gets free access to online learning tools and remote learning tools. Blind students should get exactly the same thing from the school. It's simply fair.
Hi guys, Stephen here. If you want more content like this, then all you have to do is like and subscribe to the channel. And if you want to catch new episodes of Double Tap, you can do right here on YouTube every weekday from noon Eastern, or on AMI Audio across Canada, and of course, in your favourite podcast app as well. Thanks for watching.